Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What's up, everybody? All right, let me make sure this is all activated real quick. Ooh, I gotta click two shapes. Click two shapes that are the same shape. There we go. Start this. What's up, Seth? What's up, Sensation? What's up, Jaden? Where's my screen? There we go. Turn this down a little bit. Boom! Alright, no frame drops so far. I'm happy. What's up, Seth? And
Blarg.
Blarg. And Zorn's in the house. Dude, what's up, Zorn? Zorn from Germany. I haven't seen Zorn in a second, dude. Blarg, he says. Blarg, they go. Good morning, Jaden. Yes, good morning to our Malaysian friend. Ready to get cooked? Uh-oh. He says he's ready to get cooked, dude. Oh, no. Ready to get cooked. There we go. Oh, okay. Yeah, good. Okay.
We gotta cook, Jesse.
We gotta cook, Jesse. Hey, we gotta cook. Nice. Okay, today's Tuesday. Second day of the week. Another day closer to, I guess, all the finals that students are taking and things. Oh, I need to move this over a little bit. There we go. Keep having to adjust my camera or something. I don't know. What else is new? Third day? No, it's the second day. Right, isn't this? Oh, you start your week on Sunday? Really? No, dude. The week starts on Monday. I don't believe in that Sunday, Monday, Tuesday, Wednesday. That's a conspiracy theory, dude. What? No. Anyways, when do you think the week starts, Sensation?
Wednesday.
He says the week starts Wednesday. Okay, hot take from Sensation. The week starts on Wednesday.
Do you know what? Do you want to know why?
Why?
What is Wednesday in Spanish?
Miércoles. Right? Miércoles?
Which god?
Oh, Mercury? Yeah.
Yep.
What's up, Frozen Fusion? You got Wait. Is Mercury's the start of the week? Is that how that works? Or he already started the week? Is that how it worked?
Mercury's the fastest god.
Oh, he's the fastest god.
I thought that was the Flash. Is that the Flash? You know how it works?
But Wednesday is from Woden, and who is deemed to be equally as quick.
Oh, 88 day orbit. Okay. Frozen Fusion. Did the baby voice work? Frozen Fusion? I'm curious it did. Okay, so that's why you think it starts Wednesday. My week generally starts on Tuesday, because of how I plan out the things I do.
I don't like my like work week per se ending on Friday or ending on Sunday, because then I feel like the last 2 days are a waste. Like I just don't do anything Saturday or Sunday. But if I start my week on Tuesday, then the end of my week I still get one productive day. I still get Monday to like wrap everything up that I wanted to do that week. Yeah. I feel like that's why I think it is. Yeah. Zorn said, you have a question. It's not theoretical. It's experimental. Nice. Great. Love experimental physics. Cool. Yeah, we'll go through all the questions today. I know we got a lot. Yeah, Zorn, you want to come say hi? Yesterday was dope, by the way. Like, what's up, Zorn? We had so many people find us from YouTube Shorts. I'm just going to show some metrics real quick. What was it? It was our live stream. What was it? Yeah. Guten Tag and Guten Morgen. Yeah, this one, dude. Look, we got 30,000 views almost on our live stream yesterday. 258 watch hours, and peaked at like 321 people. Bro, I've never hit anything close to that on Twitch ever. 320 peak viewers. That's nuts.
What should be 5 today?
Yeah. Well, we're already at 14 right now, so we're doing okay. I don't know. The algorithm just hits sometimes when it hits. But to anyone, yeah, because I know I have some other friends, right, that stream math stuff on Twitch and stuff. I think this speaks to my general advice, which is always try to put your content on as many platforms as you can as possible, because you never know which one is going to like find the right audience and like boost you to, you know, get more engagement. And I think yesterday was definitely YouTube. I'm running TikTok again today because I had some people on TikTok complain, being like, hey, you're not live streaming anymore. I was like, well, trying to conserve my bandwidth. But I think we're doing okay. So y'all let me on Twitch know if a bandwidth starts dropping, and I'll try to readjust things.
Something is already going wrong. I can hear it.
Oh no, you can hear something wrong?
You.
Is it like robot-y? Like what's wrong with
Well, no, but it's occasionally janking a bit.
Oh, okay. It's occasionally janking a bit. Let me know on Twitch if it sounds bad, and I'll try to fix it. Oof. What's up? What's up, you the 2-eyed pie dog? What's up, dog? Jeff says, evil question. Since all elements are made, Jeff says I sound fine. Since all elements are made of protons, neutrons, and electrons, could you derive the melting and boiling points of various elements without looking them up? If you knew all the intermolecular forces, you could, for sure. But we don't know them. I don't know them off the top of my head. So, but you could. All those things, boiling point, melting point, whatever point, just has to do with what vibrational energies you need in order for things to like break or like come back together. Yeah. Zach says I sound fine too. Okay, so maybe it's just you, Sensation. It's not you, it's me, bro.
Surprise, motherfucker! I have very sensitive ears.
So that's like why gas molecules vibrate. Yeah, gas molecules have very low intermolecular. Here, I'll show it real quick. Very low intermolecular forces between them, which is why they're able to move around so quickly and so freely from each other, because they're not really attracted to each other. Liquids are, but it's not rigid, and then solids have the strongest bonds between them, and they're very structured, which is why solids don't really fill a space and they stay very cohesive. Liquids will fill a space but also stay cohesive, and then gas particles will fill a space but not be cohesive. That's kind of how that all works. There's a lot of cool different things with it. Okay.
Liquid.
And what liquid?
Cats are liquid.
Cats are liquid? Yeah, cats fill up. Yeah, if I fits, I sits. Cats will take up any space they can. What's up, Motion? Good to see you, Motion. See, yeah, I'm streaming again for you on TikTok. It's all for you, dude. All for you. Okay, let's see. We got a lot of good questions coming up. Jaden, you said you submitted some as well. I got some from Abhishek. That looks cool. Ooh, I like this. Wow. That's some very cool ones. I like someone submitted these. 1 second. Let me pull these up real quick. If this is your question, Abhishek, let me know in the chat which one you're in, because we're streaming on 3 platforms right now, or 4 technically. Twitch, YouTube, TikTok, and Discord. So I don't know. Yeah, it's glad to see you too. Good to see you back as well, Motion. Okay, so that's that one.
Could you maybe quickly take a look at my question
Yes.
and tell me how
Which one is
long
yours,
it
Zorn?
would take you?
Which one is yours?
Send you the paper on Discord.
Oh, okay. Oh, you sent me a big PDF. 1 second, let me pull it up.
Wow. 1 point. What
Okay.
will be?
Okay, great. Okay, I'm gonna try to speak German, I guess. Okay. Okay, so wait, this is
it's only number 3. I managed to do the
only
first
number
two on my
3?
own.
Okay.
Yeah. But do
Ooh,
it.
yes.
Have to.
This has to do with I want to say this is Biosavar is what this is, right?
No idea.
Okay, I'm gonna throw this in the chat GPT and ask it to translate for me. What's up, Abhishek? Cool. Okay, I know who you are. Nice. Hang around, Abhishek. I'll do your question. And Jaden, don't worry, I'll do yours as well. I will
Oh
get
my
to
god,
Yeah, watch this. Let me translate.
you had some German already yesterday. Lösungsansatz für Eigenwerte.
Yes, I did have someone asking German yesterday. I did. It wasn't you, Zorn. Crazy enough, right?
Easy.
Okay. Here we go. I love ChatGPT. It's just gonna translate it for me. Dope. Okay. Calculate the electric field. Dude, they fuck up their latex sometimes, and I have to be like, fix the latex. Like, Christ.
I can ask my ChatGPT also quickly.
Yeah. No, I got it. It just needed to do this. This is all I need. Does YouTube mod view look any different? I don't know. Sam, can I make you a mod from here? I forgot. Here. I mean, you're great. You're like a super mod now, YouTube. Okay. Let's see. All right, now I got it. And then these are the numerical values, and then they just want us to solve this. Do they want? Okay. There we go. All right. An electron charge minus Q mass is located... Okay, and then let me get this picture. Where was the picture? You don't watch YouTube lives very often? Yeah, we just started doing it because we were getting some better engagement on it, so... I was cool with it. Okay, here's a cute little diagram. Okay.
I think you also have to use the Taylor polynomial. I think one of my friends mentioned it, but I'm not sure.
Maybe. Negligible thickness, radius r. The ring carries uniform charge density rho l, resulting in total charge q. Its axial symmetry points in the z direction. Calculate the electric field of the ring. Okay, yeah, this is easy. At a distance along the z-axis. Yeah. Okay. So, do you know how to derive what the electric field is for a point charge? Do you know what that is?
Deriving, I think I know the formula for a radio field, but I'm not sure how to derive it.
One sec. Wait, an electron is located at the center. Wait, they're putting two charges here? That's ugly. Why are they doing that to us? Okay. They're putting an electron here, right, at the center, for minus Q.
Mm-hmm. And
then there's a positive charge density of positive Q on the outside. Total charge. Calculate the electric field along the symmetry axis. Okay. Well, the electric field's only going to be between here and here, though.
Between what again? Sorry.
Between the positive charge on the ring, and then the minus charge in the center. Charge always runs from electric field. Sorry, runs from is it minus to positive? No, it's positive to minus. So there's going to be electric field pointing in at all directions here, I believe.
Yeah.
What level of math qualifications do you hold, if you mind me asking? I don't have any math qualifications, actually, technically. I have a PhD in physics, so take with that what you will for my math qualifications. But I know a decent amount of math. Okay, I know what this question is. It's this. Electric field ring of charge.
Just a quick segue.
What's up, dude?
Remember
this
how
is
I
it.
always go Remember how I always shout, "It's maths" with a plural, and
It's maths.
Americans. Apparently, loads of Americans have started saying maths now.
Oh, have they? Wow. Yeah, we say it's math.
I say it's meth.
I say it's meth. Okay, this is the thing we want. Yeah, this is
Yeah,
the the teaching point for this, right? Like the electric field. If you had a
Well, to
bunch
be
of different, yeah.
I need to catch up on some lectures.
Okay.
That's like one of my weaknesses is going to lectures. So
Your weakness is going to lecture. What is it? Just like
Yeah.
really boring? It just like sucks.
it's difficult to me to pay attention, and then
Oh,
I just
I see.
it's-
You just space
Yeah.
out. You're like, yeah, donezo.
whether I go or not go, it's no difference.
I see. Yeah, you need like a controlled environment to learn. That's okay. Okay. Here's usually what an electric field is, all right? An electric field is equal to KQ over R squared is usually what it is. Okay? This is usually how we find the
Yeah.
electric field due to a point charge.
K being 1 over pi.
4 pi epsilon naught.
E.
Exactly.
Yeah.
Now, if instead of saying Q, I say that this Q is now equal to the charge density. So this is like dq. So dq would be equal to the density, the linear density of it times like dx.
Times volume.
Right, exactly. Yeah, linear density times like linear displacement. So that's where this is like dq. What age was I when I got my PhD? I don't know, I was like 30. I took a while. I took the scenic route. I got my undergrad degree at 21, but then I just decided to like take a little bit for my PhD.
Wait, to follow that analogy, where am I
yes.
at then? Am I
That's
taking the
okay.
mountainous route or what?
You're taking the mountain. Sensation's taking the super scenic route.
That's dope.
You're still on the
Just
route
going
though,
to the moon
dude.
and back. Just-
That's all that matters. You're still on the route. Okay. So that's where this all comes from. Okay, cool. The Z over R though. Do you know where the Z over R comes from? That's actually pretty cool. So,
C over R.
okay.
Maybe that's the.
Yeah.
Well, there's no absolute value. I thought it would be the direction, but no.
So if you want the Z component, so in this case, if you want the electric field, right, points all like this, right? Let's just take an example
The
bit,
charge.
like right
Or-
here. Yeah, so for an amount of charge here, which would be equal to lambda dx, right? This is your like dq, right? Right here.
Yeah.
The electric field from that at a point Z, which is located here, right, will point in this direction, which means it'll have components, right?
Yeah.
It'll have this component and this component. And I want specifically this component, right? Which, right? So that would equal to like, I would say E sine theta, right? That's how, or cosine theta, sorry, my bad, sorry. E cosine theta.
Yeah.
Do you see how that would give me like the Z component of it, right?
Yes.
Good. So the other thing I can see for cosine of theta is that if this is also theta, right? Cosine of theta is adjacent over hypotenuse, which is equal to Z over R. So that's why when they get here for DEZ, so this whole point here, this is all like DE, and then this makes it the Z hat component of it.
Okay.
Okay?
Yes.
Cool. Yes, and so the integral required to find the electric field, right, is now to integrate this. And here they're doing it from an angle A to an angle B. And they're doing it from like a point A to a point B. So they're doing it in terms of dx, and then they're writing out everything here in terms of x. So their r squared has z's and x's, blah, 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 blah. Okay. So this is how you find it for a line of point charge. That's a little bit of a good primer to it, yeah? But now let's consider a ring of charge, okay?
Yeah.
So this is going to be a little bit different, yeah? and we're asking for the electric field, right, at some coordinate z here, right? I don't like this. What are they doing here? Excuse me. Okay, I'm not going to do that. Okay, so in this case, if we're going to integrate, this is really cool. As we take the electric field, right, and do you see as we start spinning around and adding up like all these lines of electric field, do you notice how there will be like some symmetry that'll happen?
Yeah.
So, right, the electric field from this top point here and the electric field from this bottom point here, they will cancel out in this axis, right? Right?
Okay.
This component of the electric field will cancel out with this component of the electric field. So all you'll have is a z component, right?
Yes.
And the same thing when you do this component and the component on the other side, then the y components are going to cancel out. What's up, Devil? So, what I need to do is I need to integrate around here, okay? So so dq, right, is now going to equal like lambda, and we're going to call this like dl, right? Because I'm gonna be integrating a small specific bit of line charge, right? Call this like lambda, and then I'm gonna be doing it over like some distance dl, and then we're gonna do that around the whole circle. Okay. I'm glad I'm done with E&M.
Okay.
This is tricky stuff. And then one sec. Okay. So when I integrate over the whole thing, I am just going to get that whole charge. If I integrate just dq, I am going to get that whole charge just q, I believe.
But shouldn't you integrate over the density and then you would get the whole charge?
Exactly. Yeah. So if I integrate over dq, which is lambda dl, I'm just going to get what I would get is I would get k times lambda, or sorry, not k. Let's just say just the dq. I would get lambda times 2 pi big R, right? This is also equal to the same total positive charge that's on the ring. I actually don't know why you need lambda right now. I don't think you do. Because what's going to happen is you're going to have this whole charge this whole charge q, which is all the way around, and then I'm going to multiply it by k, and then I'm going to divide it by the distance. But the distance it's located at is this like little r. So little r squared, or it's k, is it kqq over r? One sec. Is it r over r? Okay, it's over r squared. So it's little r squared, but little r squared is equal to the square root, or is equal to r squared plus z squared. Does this make sense so far, Zorn? Sorry.
Just a moment. R squared is equal to big R squared times.
So this right here, this here is little r, right? This is the distance.
Yeah.
I'm along my axis z, and I'm looking at my line of charge around this hoop. That distance, little r, is equal to the square root of this squared plus this squared, because it makes a triangle, right?
Yeah.
Okay. So that's going to be kq over, and then we're going to say this is big R squared plus z squared. Yeah?
Yeah.
But then I'm going to make the argument that... Oh, thanks for the rose motion. I'm going to make the argument that all of the horizontal component of this electric field is going to cancel out. This is E&M. Okay. So I want just this component. I want just the z component. And so that would end up being times cosine of theta. But if this is theta, this is also theta. And cosine of theta is adjacent over hypotenuse. Okay. So that's equal to z over the hypotenuse, which is then the square root of r squared plus z squared to the 1/2. Okay, so I think the electric field ends up becoming just kq z over r squared plus z squared to the 3/2. That's from the line of charge. I pray for you, G. Good job. Yeah. Okay.
So
I think this is what it is.
Just a moment, because I have the
Oh, you have the answers?
solution.
But that's only to the ring of charge. That's only to the ring of charge. And then technically I need to subtract that from k little q over z squared, because this point charge will provide a negative electric field to oppose the positive ring of charge. So this should be the total thing, and then this should be in the z hat direction, I believe. I can also ask ChatGPT to just solve this. I'm curious. Solve part A for... Doesn't z change as you do the integral over dl? It doesn't. Wait, all right, maybe he's right. No, z doesn't change. And then r shouldn't change as well. So wait, someone said only r changes, z is a constant distance. But r doesn't change either, guys, because r is the distance from a sliver of charge on this ring to the point where I'm measuring the electric field. So little r is going to stay constant as well.
I sent you the solution of my friend, and the good thing is he didn't write a lot of German, so it's basically just equations.
Okay.
And at the top, just a bit higher, that's the number 3.
Sure. Okay. Wait, did he get the answer?
I'm
Oh, yeah.
not-
He gets the same answer. This is the same.
Is it?
Wait, he's forgetting... I think he's forgetting the other charge, though. So wait, he gets to this. Interesting. So he keeps it in terms of PL times... Wait, R times Z? Okay, let me try to... Okay. Q...
Well, he used polar.
Yeah, no.
coordinates.
So Q is equal to 2 pi r times lambda. Okay, so if we were to, because that's the total charge Q. So if we were to rewrite this as 2 pi r lambda, then I would get an r, I would get a z, I would get the lambda, and then, and then k, which is 1 over 4 pi epsilon naught. You see how the 2 pi and the 4 pi cancels out to 1 over 2 epsilon naught? Yeah. We get the same answer. He's forgetting, though. He's forgetting the charge. Oh, no. It's okay. Sorry. We were just doing the electric field along of the ring. So, yeah, we get the same answer. Yeah, this is the same.
Okay, just, how is u equal to 2 pi r lambda?
Good. So Q is the total charge on the ring. So the total charge on the ring
And
is equal
2
to the
pi
linear,
r is
the circumference.
circumference. Okay.
So it's the linear
And
charge
lambda?
density times the circumference. Right? That's lambda times 2 pi big R.
And lambda is the density, the charge
Yes.
density? Or-
Lambda is the linear charge density. Yeah.
Okay.
Now, the way he did it Yeah, so he does the 0 over 2 pi. So let me just like try to explain exactly how he's doing this.
Well, so he entered. I mean,
He
you
did
said
the
that
integral.
The electric field is only going to be in the circle. and
Only
that-
only in the z direction is the other thing you have to kind of recognize.
Only in the z direction. Okay.
Which, yeah, because here's what he says. So R, he's having R only point in Z. Yes. So here's how he's forcing the Z direction by this, right? And then this is R prime, which is perpendicular to R. So if you're looking at your ring, and then if this right here is, right, if this is R, then R prime, I believe, points in kind of like this direction, right? This is E&M, Arian. Electric field.
Okay, and what is R prime in this? Like, what is this?
So he's doing from this. Oh, wait a minute. No, R prime's not a derivative. My bad. Sorry. Ooh, okay. I got you. Okay. No. Wrong. Here's what he's saying. Okay, this is R. R points to where you're trying to figure out the electric field, which is here. Okay?
Yeah.
This is R. R prime is where you're measuring the charge. Okay? R prime points in this direction. Okay? So do you see how R prime minus R gets you this? Do you see how this is R prime minus R? Yes, it's an axis of yeah. Thank you, Hamilton. Yeah. R prime is where you're evaluating the charge, which he's confining the charge to the circular coordinates, right? R cosine theta, R sine theta, and then he's forcing z to be equal to 0 right here, right?
Yeah.
Okay. And so then when you do R prime minus R, that's equal to little r here, which is what I called little r, right? Which is the square root, right, of big R. This whole distance here is big R, right? And then this whole distance here is equal to z. Okay?
Okay.
And then dv prime, so that's usually the volume of where your charge is, but our charge is linear. So that's why he calls it dl prime. And dl prime is just equal to r d theta prime. This is arc length. If you integrate over 2 pi, right? Do you see that?
Yeah, I think so. But
Okay.
I'm a bit confused about the stuff on the top.
Okay,
Like,
so
the first equation is on the problem sheet.
this is given on the problem sheet. Good.
Yeah. Then he somehow gets to the other side.
Good. No, I'll show you. So this is saying integrate all of the charge in the volume dv prime. And
Yes.
writing my integral, my charge only exists on dl prime. It only exists on this radius. So I can replace dv prime with r d theta prime. Right? This I'm going to replace with this. Okay?
So
And then
first
as
we
such,
take out the
yeah.
rho L.
the rho L is a constant. I can pull that out. Yeah.
Yes.
And then whatever, this stuff was outside as well, so that's outside as well. Cool, right? So here.
The R minus R prime
Mm-hmm.
divided by absolute value of R minus R prime, that's the direction. That's norming
Yes.
a vector, I think.
That's normalizing this. That's doing like r hat is what we say.
Yes.
Okay.
Then he replaces the absolute value of R minus R prime
Yes.
to the power of 2.
With this.
With-
With big R squared over Z squared. Well, really what you have here, do you see how you have a squared here and then another one to the first? So this is really
that's-
R minus R prime to the third.
Yeah.
So that's why you get to the 3/2 here. Okay. And then what we say from, because it's the dot product, right? And you're dotting your charge in the direction of, oh, this is the electric field in the R direction though, right? In the R direction. In
I think the problem states that this formula is just like the first principles type stuff.
Yes.
And then you're supposed to calculate EZ, and I think my friend also replaced ER with yes, he did. He replaced it
Yes.
with EZ.
Yeah. So, and that comes from the symmetry argument that all of the electric field in this axis will cancel each other out, and all you'll have left is the component pointing in the Z direction. So that's why eventually he says Z hat here, right? Which, let's see. So this is going to get you a 2 pi. And then, is there another factor of 2 in here that's coming out somewhere? I don't think so. Yeah. Because 0 to 2 pi of d theta, that's just going to pull out a 2 pi. And then...
Where does he plug in 2 pi and 0 when he integrates?
When you just integrate d theta. None of this shit depends on theta.
Oh.
You can literally
Just arrange
pull
it.
everything else out. And you're just integrating 0 to 2 pi d theta. Right?
Okay.
But
just get 2 pi minus 0?
yes,
Uh,
I do believe you still want like some component here. Yeah. Because I still want where is it? I still want the component in the Z direction. So I'm trying to see if there's like a cosine theta, because like is this a 2 or a Z? Like what's happening here? Is this ZZ hat?
I think so.
And also, why is this on the bottom? Oh, okay. No, this is ZZ hat. Okay, because then this is coming up here. Do you see that?
Yeah.
Okay. And then he just leaves the Z hat. Okay. I want to know how he got from 6 pi to just 2 here, right? PLRZ.
Maybe
I agree
you
with that.
Well, when you integrate and you plug in 2 pi, maybe 2 pi cancels out with 4 pi.
Oh, is this a 4 pi or a 6 pi? What is this?
4 pi, I think.
Oh,
because
okay.
that's just,
Oh, then we're fine. Then cool. Then this is 2 epsilon naught. And we're good. Yeah. I mean, whatever. This is the strictly algebraic way to do it, you know? Or I guess this is vector calculus technically. But I think the better way to learn this, if you want to learn like actual physics, is to think about it in terms of this. You have like little bits of charge, and you're integrating all those bits of charge around like around an arc or something. And then you make the symmetry argument that it only points in the Z direction. I understand like from a calculus standpoint why this works, but I don't think you really see much of the beauty in it. You don't really see why it happens. To me, it's cool that like all of these components cancel each other out, and you just have Z hat components, and that when you're integrating around the charge, it's 2 pi r lambda, which is just equal to Q. Yeah. Does that make a little bit more sense? Yeah.
it does make a little bit more sense, but I'm still a bit... I understand that he integrates, that his integration things are 2 pi and 0, because that's a circle.
Yes.
But I still am a bit fuzzy on how he goes from the whole term on the left side to just r d theta divided by r squared.
Oh, how he goes from this to
Plus
this?
squared.
Or how he goes from this to
Nope.
this?
How it goes from the second thing you said, how it goes from the total left
Okay.
side to the right side.
Okay. Well, also this is a simplification of this once you do the integral. Okay. All right.
Okay.
So, can we agree that all of this is just r minus r prime to the third?
To the third. Yes.
Okay. And remember that r minus r prime is the same thing as the square root of big R squared plus z squared. Do we understand where this came from?
Not quite.
Okay, then let's show. So, if I have... Bro, how do I send... What are you trying to send, Gamma? What's up, dog? What are you trying to send? Okay, so this is my z-axis, right?
Yes.
Oh, Actual Discord is the website. Yes, actualdiscord.com is the website, yes. Good job, guys. All right, so this right here, this is R. Yeah?
Mhm. Yes.
And then this right here, which points to my charge, this is R prime. Okay?
Yes. Yeah.
So then R minus R prime, right? That's like taking this vector and then subtracting what is it? This one? Oh, one second. Oh no, sorry, it's R prime minus R. Sorry, I had this wrong. Oh, but R prime minus R is the same thing as R minus R prime. If you're taking the absolute value of it, right? Let me see the way that they did it in your question. Sorry, did they say R minus R prime or R prime minus R?
In my question.
They do R
they
minus R
said
prime. Okay.
R minus R prime, yeah.
Okay, that's fine. Okay. So R minus R prime would then be this vector, right? And then the minus of this, which would be this, okay? Which would then point in this direction, right? Do we see how this right here would be R minus R prime?
R minus R prime. Yeah.
Okay. Now, the magnitude of that, right? The magnitude of that distance is just equal to a Pythagorean thing, right? This is equal to the square root of this side plus this side, which that has a length of big R, because that's the radius of the charge. And then this part of the triangle, that's the distance to where you're measuring the electric field, and that is big Z. Okay?
Okay.
Do you understand that so far?
What is big Z again?
Big Z is the distance from the origin to where you're measuring the electric field.
Okay, yes.
Okay?
Yeah.
Okay. So now if I know this is equal to this, and then this is this cubed, right? Do you see how that's going to give me R squared plus Z squared all to the 3/2?
Oh. Yeah, I think now I understand.
Good. And then R minus R prime, right? Is... Well, okay, we'll get to that. One sec. Oh, okay. One sec. Okay, so then dv, right? This is just going to be equal to r d theta dot, right? That's where this comes from.
Okay.
Okay. And then
But
here's the
isn't
key.
that,
Yeah.
Isn't dv just the volume of the...
It's the volume of the
Wow.
charge. This is the volume of the charge that you're integrating, but the charge is constrained to a circle that is
Okay, yeah.
0 to 2 pi, and you're integrating r d theta.
Okay, yeah.
So this is like the arc length, basically.
Okay, yeah.
Good. Hamiltonian dynamics. You're correct that unitwise dV is a volume. That's if I had a volume charge. I have a linear charge, which is why I use RD theta, because it's is this Calc 3? No, this is advanced physics. This is E&M. Okay. So here's the last bit. Here's the last bit of trickiness, okay? Which is this R dot R prime. Notice how this is not a magnitude, right? This right here is a vector. Right here. Okay, right?
Yes.
And you see how that's a vector that points basically from wherever my charge is in the direction of where I'm measuring my electric field?
Yes.
Okay. Now, this is where you have to make a physics symmetry argument, because as you integrate around the circle here, okay, this vector is going to have its x and y components cancel each other out. Okay?
Yeah. Yes.
So all you want is the z component of this. Right? I want the z hat component of r minus r prime vector, okay?
Yes.
Okay. And so we're almost there. Give me a second. Cuz it's missing a z here. So that's just going to be equal to z? Yes. Okay. If r minus r prime is this, and I only want this component, then I just want the z component of that vector, which is just z. Right? If r prime points this way, r points this way, and then r minus r prime points this way. And so the z component of that is just the z coordinate.
Okay. So the z coordinate is the hat.
It's just z. It's just z. And then the z hat enforces that my electric field points in the z hat direction. Because this is still a vector, right? That still has a magnitude and a direction. Okay?
And is absolute value a scalar or also a vector?
Yes, absolute value is a scalar. These are scalars.
Okay.
So in order to get the z component of this, I take what the magnitude of that would be. Well, the magnitude of the length of this in this direction is just z. And then I dot it with z hat to tell myself, oh, it's going in the z hat direction. Yeah. Does that make sense? A little bit better?
I think.
Okay.
The only
Cool.
problem is that I have to present these questions. I have to solve them for my class in order to even be allowed to partake in my exam.
Yeah.
So yeah.
You'll get it, dude. I mean, I don't like this. This is like too mathy. I like this. I feel like this is a better way to explain it. And it has to
So
do with like
when-
line charges.
When do these other things come into play? When he defined that R is just 0, 0. Okay.
Yeah.
I think. That's
If you
just-
want, I'm gonna give you this link right here. This is what I like to use
Yeah.
for learning physics. It's old school classic shit. It's called hyperphysics. But this has all the different like cool different ways that things can like make fields. Yeah, this is old school. People don't know about this. It's called hyperphysics. Here, I'll link it in the chats. There's one sec. Let me link it in the there you go. There's the chat as well.
Thanks.
Okay. Okay. I got a couple other questions I gotta help people with, but hopefully that gets you a start on stuff. Cool.
All right. Yeah. Thank you.
All right, you're very welcome, Tim. Okay.
I wish all of you a good night. It's
Thank you.
2 o'clock already. where I am,
Yes.
so-
Good. Guten Nacht. Zorn from Germany.
Hello, can you hear me?
Yes, Jaden, I can hear you. All right, thanks for waiting,
Bye,
Jaden.
good
Bye.
Okay, good morning.
Goodbye, Zorn. All right, give me a second. Give me 1 second, Jaden. I gotta announce some things to the chat. Who's it says? Is there a large queue? Yeah, there's about 3 or 4 questions I gotta go through so far. But if you
probably more by now. There's more by now too, probably.
okay, there are a lot of questions. We're getting popular on TikTok and YouTube and all the things. But if you hang around, I will do them. Just you know, come along for the ride. Yeah, what's up, Distant Defonce? W Germany. Okay. All right, Jaden, I can help you out with like a couple. I can do like 1 or 2 maybe. I don't know if I can do all of them, but if you hang around, I can do the rest of them. Which one do you need help with? Which one do you need help with the most?
Which one did I send you?
I don't know. You know what you sent me. I don't know what the fuck you sent me. What'd you send me?
Let me check. I sent you in the general chat thing.
Yes. Also, if you have questions, feel free to ask the other people in the chat. You know, this is something I will introduce. I'll introduce a way for people to see questions being submitted. I think that's a good idea.
I think I sent you in the office.
Is this
hours.
Is this the question you need, Jaden? Is this one?
No.
No.
It's the office hours. The group chat in.
Okay.
In just.
Okay. 1 sec. I don't have any major. I'm done. I got my PhD in physics. I'm fucking out. No more school for me. I say that for now. All right, which one do you want? Is this IQR?
Yes.
This is okay.
Yes.
Cool. You need help like how to do this? I mean, this isn't like too bad.
I sent some light question. Why do I feel like that's a lie?
I sent some light questions. Yeah, y'all with the light questions. What about another PhD? Stop. No. Okay. What do you need help with?
Sure all of this.
What do you need help with, Jaden? Like,
it's 2 questions. So I don't know which just two questions. I don't know how to do.
okay. What 2 questions?
What? Can you explain the meaning of all that?
The meaning of all this shit right here? Yeah.
Yep.
Okay, cool. All right, so range refers to like what's the smallest value and like what's the biggest value, and then you subtract them. Okay.
Okay.
So I'm gonna do it for this data set because I don't know, this data set looks kind of ugly with all the decimals. I don't like it. Okay.
I meant to.
Okay. So range, right? So you got to look through here and figure out what's the smallest. Okay. The smallest number here is equal to 111. Yeah. What's the biggest?
111.
Yeah. Or 108. 108. Oh no, I messed up. 108. 108 is the smallest.
So is maximum point is 678, right?
Yeah, 678. Cool. Yeah. Okay. So then you just subtract them.
Minus, oh.
Yeah.
Okay.
So the range is equal to 678 minus 108, which is going to be equal to 570. I do that right? I think so. Yeah. Cool.
560.
Okay.
No, I think it's 570. Did I fuck up? I think it's 570.
I'm not even paying attention.
It's okay. Okay. That makes sense? Yeah? Okay, so then to do all these other ones, you have to put these in like numerical order, okay? Which you have to go from like smallest to biggest. So I'm just gonna ask ChatGPT to do it because I don't want to like waste time doing it.
While you're doing that, let me just quickly jump in and say,
what's up?
Foundation GCSE is not functional skills. Functional skills is level 2. Foundation GCSE is level 3.
Oh, okay. The GCSE master here. He knows what's up. All right, here we go. So here's what you need to do next, Jaden. You need to take these numbers, and you need to put them in order. Okay.
So I need to put in the orders.
Yeah, in ascending order. You need to like put them up in ascending order. Okay.
Okay.
All right. Now to find the median, you have to like count in from the outside, from the left and from the right, and figure out where the middle is.
So it's like I need to find out what's the position first.
Yeah, so we're gonna do that. So here, we're gonna do this. 3, 4, 4, 5,
Oh,
5, 6, 6, 7, 7, 8. Okay, so this right here is our median. Okay,
okay.
this is the median. Okay, and then this is also called Q2. Oh, fuck.
What's the difference between Q2 and what is Q2 and Q1?
We're gonna get to that. This is Q2, which means like the second quartile. Okay. Now to figure out Q1, I forget. Do I count from these, or I think I count from these? You want to find basically what the middle of this is to figure out Q1. Okay. So I think I'm gonna cross this, cross this, cross this, cross this, cross this, cross this. Ugh, is this it, or is it the other one? I gotta look that up.
No, Q1.
Yeah, I'm
Q1
figuring
is
out.
the. I'll type the Q1 formula.
No, I don't need a formula.
That's the formula.
Here, I'm just gonna ask ChatGPT to do it because I forget if you count the endpoint. Quartile is such a cool word. It is. Quartile means like the 25th percentile. Exactly.
Median of the lower 7. Median of the upper 7.
Oh, okay. So it's talking about the median of these then, right? 1, 2, 3, 4, 5, 6, 7. Okay. Okay, so here to
then
figure
you
out
get
Q. So to figure out Q1, Jaden, you go cross, 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 cross. This right here is now Q1.
Q1
Okay.
is the median of the.
Of the first half. Okay.
What?
So then Q3 is the median of the second half. This is Q3.
You don't understand.
What don't you understand?
So why Q1 is the first? Wait. So it's
Because
like
that's what
E-
it's defined as. It's like the 25%. Do you see how this breaks it up into 4 different sections?
no.
Okay, well then I'm gonna show you. Okay, these are all my numbers, right?
Uh-huh.
Okay. Oh, if I could fucking move my box. Okay, there we go. These are all my sections, right? So
Yeah.
this right here is a quarter. This is another quarter. This is another quarter.
This is-
And this is another quarter. Wow, thanks for the raid, Don. What's up, Don? What's up, Them? Don does raids, baby. Yeah. Okay, so do you see how the numbers got broken into like 1 quarter here, right? 1
Yeah.
quarter here,
Yeah.
1 quarter here, and then 1 quarter
Yeah.
here, right? Yeah.
Yeah.
So then Q1, Q2, Q3 just tells you where the border of those things are.
So it's like where the things are put, like a storage. Where they
Storage, good. Sure. Yeah, it's like the boundary points for the storage. Yeah, that's a good way to think about it. Yeah.
keep- So like putting things on the storage.
Yes.
Okay. Now I understand.
Now you understand? Cool. Q0? Maybe. Yeah, we don't talk about Q0 and Q4. Yeah. So this right here, right? This is the min. And then this right here, this is the max.
The max.
Good. Okay, cool. All right, so that's how you find lower quartile is Q1. When your teacher says lower quartile, that's the same thing as Q1. Median is Q2. Upper is Q3. IQR.
In the
So here, do you know
is
IQRs?
Q3 minus Q1.
Yes,
is
dude.
Q3 minus
Dude,
Q1.
yeah, you know things, Jaden, dude. Watch. Yeah, dude. IQR just equals Q3 minus Q1. And so that would be equal to 448 minus 201, would just be equal to 247. Right?
So it's like So it's range when they mention interquartile is Q3
Yes.
minus Q1.
Yes. IQR is like the range of the middle. Range is the range of
Inner
the small is of the smallest to the biggest. IQR is the inner quartile range. That's yeah, you're right, Seth. It literally has the word range in it. Yeah, it's the inner quartile.
So what if they didn't mention range? Then just write interquartile.
No, they will always say
Maybe.
IQR. They'll always ask you for IQR. Yeah.
Okay, so for the decimal part, so for the decimal,
It's the same thing.
for the ouch. How do I
Here-
look ascending order in the decimal?
You have to know how to order numbers in decimals. So, I mean, you look at like what the first number is, and then you look at the numbers in the decimals. So,
You could also play with multiplication by 100.
yeah, you could also do that.
Multiplication by 100.
No,
Why?
you don't, no, don't confuse them. It's okay. All right, here you go. Here's what they are, and I'll explain why they are. Okay. So, when looking at decimals, right, you're always going to look at whatever number is to the left of the decimal first. Yeah.
Yeah.
And you want the number that's the smallest there. See how this has a 3, this has a 1, this has an 8, this has a 6, this has a 1, this has a 0. So, this is
This
going
come
to be.
first.
This comes first, yes. Now you see, okay, do I have any numbers that have a 1 in front of it? It's like, okay, yes, I do have this, and I do have this, and I
Oh,
do have this.
Okay. Oh.
But look, 22 is less than 23, which is less than 26.
Yeah.
Right? So that's why they go up this way. Then 3, then 4, then 5, then da 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 da. Yeah.
So before, okay, think I'll try that by myself.
Okay. Cool. Does that help you out? Is that good? You can hang around and ask other questions later, but let me get through the queue of people first, you know. Is that okay?
Then I'll send you to check if it is correct or not.
Okay. Cool. All right, nice. Congrats. Mhm.
And then if I finish, then I'll send it to you by later.
Yes. Send me whatever. I'll see if I got time for it. You're good.
Okay.
Please do my light question. What was your light question? I think. Well, one sec. Let me. Abhishek was asking, and I hope he's still here. I know he's been waiting for like an hour. My bad. Abby, you still here? Is Abby still around for this question? This looks like a pretty good one. Point masses, clockwise speeds, all this omega shit going on. Wow. I'm gonna give him a second to see if he's here. Abby got a priority seat. Well, he got here first. I give priority to people who ask questions first in our Discords. This looks like Chinese. I can't answer that. Hell yeah, Abhishek is here. Okay, cool. All right, here, Abhishek, I'm gonna do yours.
Where what?
Oh wait, one
It
sec.
looks like Chinese. Or it's Chinese.
It was Japanese in the other one, is it not?
That I wrote.
No. Sorry. In help screenshots, do you see this question?
Oh,
Isn't this Chinese
it's Japanese.
or Japanese? Sorry, that's what I meant to say. My bad.
Hang on. Where is it? I can't help screenshots.
It's in help screenshots. Two are Japanese ones. Okay, I'm gonna do this one for you.
I can't see it.
Oh, really? Oh, I should be able to see it.
The fuck is going on?
You have access to that channel, I think, right?
Yeah.
Okay, let's see. A point of mass m is connected to an inertialess string of length L, the other end which is fixed to a point O. At point t equals 0, the object is assumed to begin to move horizontally in a vertical plane from the bottom at point A. Wait, in a vertical plane. Okay, so I assume this is like up down. OA equals L. Okay, so they're saying this distance here is equal to L. Cool. Okay, with a speed v naught. If v naught is between square root of 2gl and square root of 5gl, then at point B, the angle between OB and the horizontal is designated as theta. Okay, so, okay, cool. All right. The magnitude of the force acting the object from the string. One sec. TikTok's still mad at me. I have to finish a CAPTCHA. Unable to verify. You stupid. There we go. Okay. What's the question?
You're coming to it. You had to get through all the. There's multiple questions.
Okay, here we go. The speed V. Okay.
What they were doing is giving you some cases.
Okay.
Some things to work with.
Okay. Okay, they just want to know where the tension's equal to 0 here. I think that's what they're asking for, right? Yeah, okay. I think it's such like a long-winded way to say it, Abhishek. Okay, so this is tension, right? There's some tension acting on it right here. Okay. And then there's also going to be a force of gravity, Abhishek, which is pulling straight down as well. And then this is my mass, M. Okay. So then, and then what do I want to do? Okay. I want to do my sum of my forces in each direction. And then we're gonna get some stuff here. Okay, so here we go. Sum of forces in the x direction here so there's 0 from gravity, and then if this is theta, okay, that means that this thing is also theta. Yep. So this is also theta, right? If these two things are theta. So that's going to be t cosine theta. So that's going to be t cosine theta. And that has to be equal to the mass times the acceleration of the thing in the x direction. I'm going to get to what the acceleration in the x direction is in a second here. Okay. For the sum of the forces in the y direction, I'm going to have minus mg. And then I'm going to have minus t sine theta. And this also has to equal to mass times acceleration in the y direction. Okay. Now, if something is moving around in a circle, Abhishek, okay, it's also going to have an acceleration that points directly towards the center, which is equal to AC. Okay. So AC is going to be equal to v squared over r, which in this case, r is the distance from the rotation to the center, and that distance is L. Centripetal acceleration, 100%. But here's kind of the weird thing, is that AC points directly inwards. So AC points, well, really it does this. It points in the same direction as the tension. Okay? So that means that the x component of AC is going to equal to v squared over L, and then that's going to be cosine theta. And then the y component of AC is going to be v squared over L sine theta, but negative. Okay? So, what you end up getting when you plug this, for instance, into here is that t cosine theta is equal to mv squared over L cosine theta. So cosine thetas cancel. So that just gives me that t is equal to mv squared over L. It would be easier to do this radially and tangentially. I decided to do it in Cartesian just because, yeah, I'm being difficult. And then for this one, minus mg minus t sine theta is equal to negative v squared over L sine theta. Okay. So, and we're solving for t. Oh, but we say that t is equal to 0. Oh, that's cool. Oh, interesting. Wait. If the tension's equal to 0...
Is that a problem?
Yeah, it is. I don't think I want to do this in the X and Y direction then. That's annoying. It's weird because it's at an angle. So the centripetal force is just from gravity, correct? Uh-huh. And gravity points straight down, and I need to know the component of it that points in this direction. Right? Yeah. Okay. So I think I just want to use this component. Yeah, this is what I want to do. So whatever. This goes to 0, okay? So that tells me mg is equal to v squared over L sine theta. Or mv squared. Sorry, there's an m here as well. So m's cancel as well. And you're just going to get that v squared is equal to gl over sine theta. Or v is equal to the square root of gl over sine theta. Wait, one sec. But I'm off by the 1 over sine theta. One sec. Let me try doing this without doing all this stuff. I'm going to do everything in terms of just the radial direction. Yeah. Okay. Let's do it in the... Let's change our coordinate systems. It's kind of weird to do it in X and Y. Let's do this. Let's call this the X direction, right? And then let's call this the Y direction. So in the Y direction, you have t plus, and that's okay. So the component of that that's in that direction is not going to be cosine theta. It's going to be plus mg sine theta. And then this has to equal to m v squared over L. Okay. Now, if the tension is 0, then you have mg sine theta is equal to mv squared over L. M's cancel. And so you get square root of gl sine theta is equal to v. Okay. So that should be equal to this. Does that make sense there? So I changed my coordinate system is what I did. I changed it in terms of like X was pointing tangentially to the motion and then Y was pointing like in the radial direction towards the center. So now, good, yeah. So now the acceleration only points in the Y direction, so I only care about the forces in the Y direction, which is T, which we set equal to 0, and then the component of FG that points in this direction, which is FG sine theta, because it's FG cosine of 90 minus theta. So this technically is 90 minus theta. And then cosine of 90 minus theta is the same thing as sine of theta. So that's where that came from. Okay.
Is it an answer choice then?
It is. It is choice C.
You know
The initial speed V naught. Okay. So this has to do with conservation of energy, I believe. So, yeah. Okay, one sec. This is... Well, one sec.
5 Twatsons. It's a 5-part Twatson.
Yeah, no. I see it. Okay. So I think this is conservation of energy. So at point B, kinetic energy is going to be equal to 1/2 m times this velocity squared. So that's going to be GL sine theta. And then I'm gonna mark this as like the 0 point. This is like height equals 0. So then my height is going to be the y component of this, which will be L sine theta.
Nice.
So potential energy is equal to mg, and then it's going to be L sine theta. Okay. At A, Ke equals 1/2 m v naught squared, mu e equals minus mgl. Because if I call this height 0, at A, it's located a distance of minus L below. Okay. And now I just need... yeah, I don't think I need rotational kinetic energy in here yet. So now I just need the total to equal the total. So here you have 1/2 mgl sine theta plus mgl sine theta. Oh, that's cool. So that's just 3/2 mgl sine theta, right? And that's equal to 1/2 mv naught squared minus mgl. So the m's are going to cancel. And so that's 3/2 gl sine theta plus gl times 2. So that's going to be 3gl sine theta plus 2gl, and then it's the square root of all of that is equal to v naught. What's up, Faint? If I get to it, we'll get time. Oh, okay, cool. So, yeah, so watch, you can pull out a gl. So this is gl, and then it's 2 plus 3 sine theta, and then square root of that is equal to v naught. Which, yeah, that was answer choice B. That's really cool. Does that make sense there, Abhishek? Where that came from? Yes. Okay, cool. Okay, from point B for a while, the object takes a parabolic orbit till point C. The maximum elevation with respect to its location B is expressed as... Well, I have no clue how to do this one. Parabolic orbit? Why? Okay.
Enforced, you can't do 4 then either.
No, I think I know how to do this one. One sec.
Can't do 3, can't do 4.
Yeah, it's projectile motion. Thank you, Hamiltonian dynamics. Yeah. So they're saying pretend that the rope like snaps, and this thing is just in like free fall, right? From here all the way until point C. Okay. So this is just a standard equation. This is a standard kinematics question, where this has a velocity, which do we say was square root of GL sine theta? Is that what we said? Fuck, where did I put it? Oh, no.
Did you lose your stuff?
Oh, I have so much stuff today. Okay, there we go. Okay, answer was C and B for the previous ones. I just wanted to clear up some space. Okay, one sec. CB. Okay. So this had an initial velocity of square root of GL sine theta. And then they want to know the maximum elevation. Okay. So I just want to figure out where... Oh, this is kind of cool. I think I assume that the velocity in the x direction doesn't change, but the velocity in the y direction will. This is like a max height question, right? So, I remember how this works. So, yeah, v squared is equal to v naught squared plus 2a delta x. this is going to be equal to 0. This is going to be equal to GL sine theta times sine theta again, or sine squared theta, I think. Because you need this component, right? So this is V sine theta. Okay. And then we're going to say minus 2g, then delta x. And then this will tell me my maximum height that something gets to. Okay. So, delta x is equal to GL sine cubed theta all over 2g. So that's equal to L sine cubed theta all over 2. Cool. Is that one of the answers? Oh, they did it in terms of V naught. Okay, whatever. I could have left it in V naught. Whatever. Okay, so sorry. So that's V naught squared sine squared theta is equal to 2g delta x. So it's V naught squared sine squared theta all over 2g. V naught squared sine squared theta. Over 2g. Wow, that's choice A. Wow. I think these are right.
What's in your chat? I think.
What'd you ask, Seth?
Someone I think put a twats in your chat.
Oh, cool. Yeah, there are a lot of things happening in the chat. Oh, yeah, someone's putting like math challenge questions. The best way to get your question answered faint is to send a screenshot.
Some of the fifth power of the roots of the equation.
If someone in chat wants to solve that for him, I'm totally cool with that. Go for it. Is that Frenet frame? What's Frenet frame?
You can
yes. Yeah, you
it.
can call. Yeah, send a screenshot into the link down there. We'll take a look at it. Okay. In the case of theta becomes pi over 3, the angle phi for specifying point C becomes.
Okay. Someone asked you if you saw twats from someone.
The answer to the third is G. What do you mean G? G's not
Motion asked you if you saw someone's twats or not.
And I don't know. I'm still working on it. Well, one sec. He said the answer to 3 is G, but G is not an answer choice. Sorry. Abhishek. Faint is just going to keep spamming his question.
Not anymore.
Sensation's like, nope. No more. Relax, Faint. Yeah, chill. There's an order to things.
Go fuck yourself with a cactus.
Don't anger the sensation, dude.
You just keep spamming your shit. I mean, it's not like we have things to do. You know what I mean?
Yeah, I know. The kids, they'll eventually get it. Abhishek says that's the problem in the answer key. Yeah, there is no choice G though, unfortunately. You can't do it. You can't do it. There's no choice G. Oh, thank you. What's up, Zach? What's up?
Mr. Go.
What's up, Jaden?
Can you help me to check if I send you in the chat, then is it correct? I don't know how to find the Q21.
I can check that in a bit. I got quite a queue of questions I got to go through with students, but.
Okay, so if I'm gonna go to school now, so
okay.
If I come back, I'll you help me to check.
You can just stay.
Yeah, one sec. Here, I'll put. If you ever want to ask questions and leave them for people to solve, here I'll put this in office hours, and if someone wants to go at it, they can.
I'm already working on it. You're good.
Okay, cool. Thanks. Yeah, here's the here. I'll tag you, Seth.
Q2 is just. I'm looking at the twatson right now. I'm doing.
Okay, cool.
It's in office hours. Q2 is just the median.
Yeah.
Oh, okay. I'll Q2 is just the median. Okay, thanks.
Yeah. Okay. I'm gonna take a little break here, Abhishek, just because doing these two might take a little bit more time. But if I have time, I'll come back to them. But hopefully, this at least makes sense for the first three. These are cool, but I need more time, and I have a long list of students to help. So I hope this helped you at least, so far. Cool. All right. Nice. Good job. Dissonant Font says, what made you stay in the real world and study physics and not math in the meta world? I like real things. Real things are cool. Okay. Let me
I don't
see.
think 2, 1, 2, 3 are tracked.
Send DMs to Jaden if you can about that. Just ask him. Okay, let me see. We do have quite a few other questions that got submitted. Swa had one. Minimum positive solution to the transcendental. Like, which one is gammas? I'm gonna show you a bunch of questions I have. Which one is gammas?
Into top chat, I guess, is what he's saying. It was more into top chat. So,
Someone says I got a B+ in my linear algebra. Why
Oh,
are you
nice.
complaining about a B+?
B plus is great, dude. B's get degrees, baby.
B's get degrees.
No, I need to drown in hydration, Zach. Please, thank you, dude. Appreciate you.
Drown. I've run out.
You need to get some more water, dude. Go get some more water. Gamma, what the fuck's your question, dude? I don't see it. And this is why you can't dump questions in the chat, because there's so much going on in the chat.
you can dump it. It doesn't mean it's going to
For the love of God, you need to send me a screenshot.
Actualdiscord.com/submit.
Yeah.
Oh, I'm a fucking lanyard.
It's the one about a set S having n greater than to 3. I mean, here, I'm gonna look. This is what I have on screenshots. So you gotta tell me if it's here. This is Abhishek's we just did. This is Japanese. I don't read that. This is also Japanese.
It's not there then. Not there. So
Well, it's not there.
it's not there. It's not. It's not. It's
Yeah.
not- unless it's
Someone
down
sent this
below
as their
that.
screenshot. I'm confused how this is a question.
This is below that one. It's not there.
Ooh, someone asked about De Moivre's theorem. That's cool, Webbies.
We actually
What is it?
we've actually done that. We've done one.
Have we
similar
done
to
this
that
one? Do we want to do this one? Let's just
We
do
did
this one.
something similar. We used the form for a bunch of times. For a Twetson simplifying a.
What is De Moivre's
arbitrary
theorem?
entity.
What is De Moivre's theorem? I've heard that name before. What is that?
I can't even say
I
that
thought this
name.
was the one that said. I thought it was the thing. Yeah, Toastings. That's precise then of its to power is
Oh, yeah.
something, something different like.
This is why I hate French.
De Moivre. De
'Cause you have to
Moivre.
say like
Taking complex numbers and
Moivre.
polar powers.
Oh, thank you.
It's that.
Yeah, Zach's got me here. So, cosine of x plus I sine x to the n.
Power n is the same thing as
equal to-
cosine of nx plus I sine of. We've used that formula with a
We did do
about a
that.
week ago.
We did do
two
that,
ago.
didn't we? Yeah, we did. Okay.
A week or two ago.
So, this is cosine
Find the
of
small
15.
positive angle theta for which this is true.
Cosine of 15 theta plus I sine of 15 theta
is
is negative
negative
I.
I.
Well,
Your
how
goal
would you do
is to
this,
find the
Seth?
smallest positive angle theta for which it's true.
Yeah. I have an idea of how to do it. How do you think to do it, Seth, though?
Well, there's not a nice formula for 15 theta. So we're going to start that statement.
Well, we also know, like, this is the real part, right? This is the imaginary part.
I'm saying there's not a good form. There's not a good formula for something of 15 theta, as there is for like something of 2 theta
Right. So watch this.
and a 15 station like that.
So I know that this thing needs to be 0, right? In order for me to get just negative I, because you see how there's plus there's no real part here.
I see
Right?
these. I see. I see.
You
what
see
we
that?
can.
Okay, so I know that the cosine of 15 theta has to be equal to 0.
And we know when that happens.
Yeah, where does that happen?
Well, when
Happens
the
when, like-
cosine of theta happen.
Cosine of blank 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 is equal to, I think it's
Equal to
pi
0.
over 2.
Treat it as 0 for now, because it's going to be, is it 0 2 pi? Waiting for that 0. When does that happen? In a unit circle.
Well, so this happens when this thing is equal to, I think it's like 2n plus 1 over 2
pi and 0. It's
pi, right? Because on the unit circle, right?
there. Some cosine is something is 0.
Cosine's always the adjacent side, and the adjacent is always 0 here and here, right?
So when that's a 0, so it happens at two distinct point pi.
Uh-huh.
0 pi and 2 pi with radius terms.
Right, so it happens at pi over 2, or
No, it doesn't have pi
3
over
pi
2.
over 2. It does happen at pi over 2.
Isn't it
Isn't
happen at
cosine
those
of,
points?
cosine of pi over 2 is equal to 0? Pretty sure about that.
Oh, yeah. Pi over
Okay.
2 and 3 pi over 2.
So,
And
I mean, that
then
tells me
you
right
can-
away that I have two solutions, right? I can either have 15 theta equals pi over 2 or 3 pi over 2, but the question asked which one did I want?
No?
What do you mean no?
Pi over 2, 3 pi over 2, 5 pi over 2.
Correct,
7
correct.
Pi over 2.
But then,
There's
but
infinity minus 3 minus
it wants the smallest
Smallest
angle,
one.
though.
worth.
It wants the smallest angle. I want this thing to be the
The problem
smallest.
is we don't know which one we need because we can't use either one without knowing the nets.
Good. Right. Okay.
We
So
need
we're
to
gonna
get a
we're gonna
note.
leave this for now. We're gonna leave this for now.
Oh, we don't care.
Because-
Wait, don't leave it yet. Don't leave it yet. That's not theta.
Oh, okay. Sure. All right. Let's.
First it's not theta. But we want
let,
to leave it like that.
let me leave it as
because,
15 theta because yeah, I can't evaluate things otherwise. Because I
No,
know I need
I
this to
would
be
do
something,
one
right?
thing.
What do I need this to be?
At negative I.
Negative
I
1.
sine I.
I need the sine of 15 theta to equal to negative 1, right? So
Let
that
me do
this whole
something.
thing becomes
Let me
negative
say-
I.
Let me say here. I have
What's
a
that?
very simple truth that I'm going to use. I
Okay.
know what 15 theta is.
What do you know 15 theta is?
Pi over 2, 3 pi over 2, 5 pi over 2, etc.
Yeah, sure.
So we just plug it in, see what happens, and see if it works or not.
True. We could do that.
Sine of
I
pi
could
over
also-
2,
I could also recognize though, right? That sine of something is equal to
something-
negative
that's-
1.
that's the- sure.
When does that happen at? That's when it's equal to pi, or it's equal to. No, sorry.
Negative- ne- 3 pi over 2.
Sorry. It's only equal to negative 3 pi over 2. Yeah.
No.
Or no, sorry, 3 pi over 2.
No. Thank you.
Okay.
Negative
there
3 pi over 2 is 1.
3 pi over 2 plus 2 pi n. Right.
Yes. And then there's their result.
And
right?
there's our
3 pi.
solution, right? There's our solution. So
That's
this
the only
is
limitation with this
good.
must be true.
15 theta equals 3 pi over 2 plus 2 pi n.
So there,
And then the smallest solution is when it's equal to 3 pi over 2.
which is not
So-
correct. Which is not
So we
correct
still got
yet.
to. We're not correct yet. What we got to divide by 15, right?
Divided by 15 in state. Yep.
3 pi over 30
Which can be simplified.
pi over 10.
I would say approximately.
Is it pi over
Can't
10?
you
Or you want me to
usually
approximate?
approximate there.
Uh,
when you don't need to.
bro, we know what this is, right?
We can pretend it is, and we can say it's approximation, but we know what it is.
3.141596. These are the most amount of digits of pi I know. I don't know if people know
What I'm
more.
saying is that's not pi over 10. It's not approximately pi over 10. It is pi over 10.
It is, but to approximate that, right? All I got to do is move the
We don't
decimal
want to
over.
approximate. We want to state it pi over 10. As you state right now, we already have. Theta equals 3 pi over 30, which is approximately equal to pi over 10.
Oh, I see. Okay, is equal to. Yeah,
That's the problem.
there you go. Okay, cool.
Problem is this.
Okay, answer's pi over 10. Nice. Good
what's
question.
Yeah.
There.
A theta is approximately that if you don't want to state it.
Yes, exactly. Nice.
You gotta state theta.
Cool. That was a cool question.
What's the other one? Was it,
Good job,
and then
Webbies. I kind of like that question. That was fun, Webbies.
Help
Fun.
screenshot ones then.
Yeah. Let's see. Yeah, again, if you have a question, if you're finding us on TikTok, YouTube, or whatever, please, there's a website down there, actualdiscord.com/submit. You can go. I think actually now I set it up so you can actually just go to www.actualdiscord.com. Oh, well, that fucked up. Okay, you still need to go to submit. I actually don't know why it's showing this.
Just change
Okay.
races then, right?
Yes, we'll go through. So thank you for answering that. Is it? Oh, a similar question popped on your math exam. Oh, cool.
Get your rates.
Yeah, if you have a question, please put your username here, choose a file, upload, and we'll get the question here and we'll do it on the stream. You can also watch live on Twitch. You can join our Discord. You can visit our YouTube. And I'm going to put an additional link here because I'm not the only person that does this. We have a bunch of other friends that do math and science tutoring, like streaming stuff. And here's the calendar for when they stream. So Zach was on earlier this morning at 9:30, and he'll be on tomorrow morning at 9:30. So if you want to, find out when to get help when we're not here, please go ahead, check out this calendar, and go give those guys a follow. They're really awesome. Okay. Shantrix had a question?
No, that was yesterday. Where you are, where you're tied up
I got
to.
another thing in the screenshots. Ooh, Zark. Zark has one. Ooh, I know this question. I know this one. Zark. This is E&M. Again, more E&M. Okay. It says a non-conducting rod of length 2D lies along the x-axis and the xy plane. Okay. Half of the rod has a uniform negative linear charge density, negative lambda, and the right half is positive lambda. Which integral expression can be solved to determine the x field of the electric field at point P, which is on the x-axis at x equals d?
And within for the x opponent only.
Yeah. Yeah. This is always like setting up the integrals is weird. So, okay. Electric field is always equal to the integral of k dq over r squared, where dq is usually equal to some like lambda dx or lambda dr sometimes. Yeah, or lambda dx. We'll just say it's lambda dx. Okay. So let me just worry. Yeah.
We want dx stuff. We want this.
I think we want dx because this is in the x-axis, right? Yeah.
No. Here's the reason we want it. Read the answer choices.
Oh, yeah. All these things have dx.
They're on dx.
There's all of a dx. Okay, cool.
So we don't have to. So it's in the x form.
Okay. So let's think about where setting the bounds here. This is where this question gets tricky. This question is tricky because of bounds. So
we can do bounds. We can do the r squared term. Right?
Well, the r squared term. Well, no, and that has to kind of do with the bounds, is what it does. How far in the queue is my question? Descendant fonts. When do you submit yours?
He's probably at the bottom. He's probably at the bottom.
Which one are you? Well, wait. I gotta see.
Not that one.
Oh, you just submitted? Oh, you're probably one of the next ones then. Yeah.
No,
Not too far.
Is he the next one? If
Right.
Okay.
Yeah. Well, here. Let's do this. Okay. So
we have the help screenshot ones too. So
yeah,
maybe not
I'll see what's in there.
but-
So I think I'm gonna integrate. I'm gonna
Yeah,
integrate
sorry,
from.
you are.
I'm gonna integrate from D. This. You have to like define what x is. Okay. Let's call this x equals 0. All right. Then I'm going to integrate. I think I'm going to integrate from here to here. I'm going to integrate from 0 to d, and that's going to be k, and then that's going to be lambda dx, right? Because this amount is lambda, and the amount of charge there is dx. And then I need to divide that by the distance from this coordinate x to here. So this is called, this is my r. Okay. So r is equal to the big distance, little d, minus x. So this is going to be d minus x squared.
Now it's, and then we have to add to the other version, the top.
Good. And then we have to do the other part. So the other part. So this was just for this, for the positive
Before you go on,
sector.
Ben,
Yeah.
I don't know if I'm gonna be right about this. On the answer choices, and just if you scroll down on the C and D, don't think either of those would be right then.
They
don't
might
have a
by
tab.
symmetry. We got to see by the symmetry
Oh,
at some point.
okay.
Yeah. I'm going to show you. There's something weird with the symmetry. because when I do
What is it?
this, so if we do this component right here, right? Now lambda is negative. So now I'm integrating from negative d to 0 of k times negative lambda dx. And now this distance, Seth, right? That's equal to...
We don't have a point on this case, though.
Well, wait. Okay. This is equal to whatever the distance x is here, but x is negative, right? So I gotta remember how this works. I know it's d. It's definitely d. I think it's also d minus x squared.
Is
Because
it,
think, right? Because if this is x, right, and let's say x is like negative 3,
negative. Well,
then that adds to the distance, right? It's still d minus x.
So
Yeah, that's cool. So,
add x
do-
was addable.
do you see how? Yeah, do you see how this is like symmetric now?
It's not twice. There's the bounds need to be flip flopped.
Yeah.
We need to flip those bounds, or this is not addable.
What do you mean? Sorry, what do you mean? I need to flip the bounds?
Negative d
Well-
to 0 and 0 to d. They're not on the same bounds, therefore they're not added. They can't be added to each other.
Yeah.
We need to flip the bound and cause the sign to flip.
I see. But then that'll make that 0 to minus d, right? And that won't really
That's
help me out.
0 to.
Is that I gotta remember how.
Read the
I know
choices
like
and see.
integral of the a to b is the same thing as negative integral of b to a. But what happens if you put negatives on here? Okay.
This is an answer choice yet. Let's maneuver the k and lambdas out, though. We don't need.
Oh, I
them.
think it's b. Is it not b?
I don't know.
I think it is.
I have
Look,
to I'm reading the. I'm
0 to
reading through what
d.
it says.
it's
I
0 to
thought-
d k lambda dx over d minus x squared. And then it's minus negative d to 0 k lambda dx d minus
yes.
x squared.
And
Ah.
was moved out. Yeah.
Hamiltonian dynamics is right. I'd have to do a change of variables to flip the signs on the limits. Okay. Well,
Yeah.
so I think this is the answer choice.
And A's not at all. A's a negative. Yeah, A's a no. A's a definitely no. And then
Yeah.
C and D wise.
I think answer is just B. Or we can test this too. We can go chat. We can go to chat tizzle. Just go solve. Go my AI slave lord. Yeah, Webbies. Yeah, be patient. Yeah, please. This is so cool. It's showing like how it's doing it. And here, yes, Faint, because you've been saying your question enough times. I feel like I've done this one. All right, while we wait for ChatGPT to figure that out. Which,
What is his?
one sec, I want to pull this in. Have we done this
that.
before? Have we done this one?
Maybe. Oh, ChatGPT because it should be done by now. Yep, B.
Yeah, answer choice B. Nice. To latex
You
5,
just
yeah,
Power
100%.
of the root of the equation. Find the sum of the digits of Q.
I like this and then fonts. You submitted 2 different ones. I like your second one better than your first one. This and then fonts. This one looks a lot nicer than whatever hot garbage this is. What is this dissonant fonts?
That second one I will happily do if we had it.
Okay. Let's see.
that-
QB the sum of the fifth powers of the roots of the equation. Find the sum of the digits of Q. Well, this is just annoying.
Okay. Fifth powers of the roots.
Okay. So we have to go find all the roots, then we have to take the fifth powers, and then we have to sum them, and then we have to add the digits.
Well, we don't have to, do we? Necessarily? Okay, let me ask you, what do you think they mean by fifth powers of the roots? That's the first part. Understand jargon?
I think it's like root 1 to the
The ability
fifth
to
plus like
figure.
root 2 to the fifth, no?
What's that jargon up like? And see what it tells you.
Look
Do
up
that.
what? Sorry, what are you saying? Look up what?
Fifth powers of the roots. Just that specific wording. We don't understand the question, we can't solve it.
I think fifth power of the roots is just the roots.
not.
Yeah.
The fifth root of an. Nope, that's not that.
Oh. Wait, what? What's up,
fifth
Swift Ray?
powers, change your wording. See if it changes it.
Fifth power of the
Just gonna
roots?
make Power.
Yeah.
Pattern of the root result. Yeah. Wait.
Okay.
Read. There you go. Yep. What you said.
Yeah.
Result
Right.
of raising a root or roots of.
Yeah, I'm
polynomials
just raising all the
raised
roots. I'm just raising all the roots, yeah. I don't know if there's like some special theorem here,
Yeah.
but
Okay, now can we do it easier way?
I think we just got to figure out the roots. Well, I know the roots by the rational
I'm
root
not a fan
theorem
of-
have to be like either like plus or minus 1 or plus or minus 3,
Yeah.
right?
Here's what we know. Here's what I can say. Here's my
What are you going to say?
fundamental thesis. There must be 4 roots.
Yeah,
They should be imaginary for all we know.
I hope they're not.
For all we
Really
know.
don't.
That's what I have to say. That's my starter. They should all be imaginary, 2 imaginary, or none. We have to make that.
I think we should just
Minus-
try negative. Can we just try -1? I think we should do that, right?
Now, if you
just
want to
try-
speed this up,
Let's just try -1.
if you want to speed this up, go to Desmos and graph it and see what it comes with.
I could. I want to show the old school way of doing it, though.
We only need the
We-
first one, and then we can test. Yeah, so -1, and then testing.
-1
Then
doesn't
start
really work
testing
though,
it.
right? Because that's 1. Sorry,
One-
or no, maybe it is. 1
1
minus 7 minus 4 minus 3. That doesn't work,
Yep.
right?
Is not right. Probably 1 now.
That's
1
1 minus 7
4
plus 4
minus-
minus
that
3.
would be
No.
Better. Nope. Try 3. 3's gonna be bit, but it might work.
Oh,
81.
man.
I got it. You're good. 81 minus 63. Just right as I say it.
Uh-huh.
81 minus 6 plus 12 minus 3. Better. But no, that's not it. Okay, -3. 81 plus 63.
Plus 63. Not gonna work. So Jeff's right.
Minus-
Yes. Yeah. The issue is it's not gonna work. The issue is that the rational root theorem only gives you rational roots.
And these are rational roots. Lovely.
Okay.
Then
So
these are
someone gave
rational
me. Someone just made my life difficult for no good reason.
Yeah, try Desmos. Because I want to see if Desmos.
I'm just gonna go to fucking Wolfram
if,
Alpha.
if it doesn't give, if it doesn't, see what Desmos says, and we can check to make sure that I just
Okay.
did my math right.
Yeah. What was it?
Desmos
So
is their catcher. Is if Desmos said if Desmos doesn't have a draft crossing the x-axis, we know it's annoying.
minus 7x squared plus 4x minus 3.
Yeah. Let's see what it.
Can you
yeah,
use
so
that stuff
Wolfram-
out some of the roots? Yeah, maybe. Okay, so it does. So it has 2
It
real
does.
roots, which are irrational, and 2 complex
Bitter.
solutions.
Now we get to the 5th power of these and add them together.
Oh, here we go. The sum of the
Sum of
roots is
roots.
0. This is cool. Sum of the
it's
roots
not,
is
it's
0.
fifth power.
Product of the roots is minus 3. That's what you're saying, Hamiltonian, right?
5th power. So we have the 5th power, then add them.
Yeah.
We have to
So that's
add
not.
5th power each of the roots. Then
That's just
add them together.
ugly.
You done messed up, Aaron!
That's just so
I
ugly.
mean, easier way then probably. Says you're
Bro, this is the exact form. Get the fuck
Yep.
out of here.
there's probably an easier way then, right?
I don't know.
That's what we
That
can
or
make an
like
announcement
that
about.
or Faint
Oh, yeah.
is just a
Either way
troll
works.
in my YouTube just spamming me like an impossible question. Which
Then
happens. It hap-
impossible.
Here, I'm gonna send fucking ChatGPT at it. There's a cool way of solving every single polynomial using Newton's identity. No wonder he asked it so many times, right, Webbies? Yeah, dude's just being a
It's a trap.
fucking asshat. Okay.
He's gone anyway.
Yeah, it's okay.
So there is real
I'm-
roots, but not
I'm curious. I'm curious if ChatGPT can run this though. All right, we're gonna leave it running for a second. All right. All right. Descendant Fonts
Now we do
is
the
a
integral.
is a friend of ours, and I know is not an asshat who's just gonna like spam like some bullshit time wasting question for me.
What was the what did you do though?
I don't know
Really?
how to do this
First-
Descendant Fonts. I really
Let's do the
don't.
integral then.
I will do the integral,
Integral.
but just for style points, Descendant Fonts, I will at least like humor this. The subspace
before-
of spec A consisting of maximal
Yep.
ideals with the induced topology, dude.
About the other.
What is this? What?
What is about the?
I love you just in end fonts, but no.
What
Okay,
did-
this one
what
we
did it
should be
say
able to
about
do.
the other?
I think we should be able to do this.
What did it say
Oh.
about the other?
Oh, okay.
Scroll.
Well, apparently the answer is 5.
Okay, so why?
Newton's identities, where Ri are the roots of
Okay.
this. The recurrence
Where R
for
are the
k is
roots.
greater than or equal to 4. Bro, what?
Oh, it's testing it. Okay. Interestingly. Huh.
Yeah, I don't think I would have gotten this one.
Okay, good.
Oh,
So,
whatever.
integral.
Cool.
Wait.
All right, let's do the integral.
Let's see
I like the integral.
That's the first thing. It's annoying. Yep. That looks to be a annoying integral.
Well,
In the sense of it's not. It's gonna be.
nice, Fembox. You got the sum of the squares is equal to 14.
It's the
Yeah, we need the
fourth.
sum of the fifths.
So one. So.
Hmm.
So this is gonna be using our integration stuff, not doing.
The issue is that like this isn't like a difference of squares or anything. Neither is this.
It's not. It's x plus.
I could expand
Is it-
this. I could expand it.
X
Just-
plus 1 might be a bit nicer than a Lutz. Is what I'm gonna say to that.
I think we use a trig substitution here, maybe.
Maybe that might be. Let me. No, I can't. My sheet won't have it.
I think if I say like x is equal to tangent squared, or is equal to tangent of x, or let's sorry. X equals tangent of u. Then
Before we
1 plus x squared is equal to oh no. X equals secant of u, I think. Right? I'm forgetting my tangent identities.
let me see if tangent is. I got it. I got that.
Oh,
Yeah,
okay.
some
What
of
is it? Is it 1 plus secant or 1 plus tangent is secant? Which one is it?
I'm looking for tangent squared plus 1 is secant squared.
Okay, sorry. So then I want this to be secant
That's not-
of u. So then 1 plus x squared is equal to 1 plus secant squared of u, which is equal to tangent squared of u, right?
No, it's not. 1 plus tangent squared is secant squared, though.
Oh, sorry.
I was giving you what you asked for, which is what is 1 plus secant.
Okay, there we go.
1 plus
there we go.
tangent. 1 plus tangent squared is secant.
Okay, cool.
That's what we care about.
Okay, and then dx is equal to secant squared of u du.
Well, what is secant squared? What is the
Right, derivative of
Derivative
tangent
of
is secant squared. Okay, this actually
Derivative
works
of
out.
secant
This works
squared.
really cool. This is watch this, Seth. Right, because x
We need
This
to
is now-
read secant before.
this is tangent to the fourth of u, right? And then this is 1 minus
Minus
tangent of u all to the fourth.
the fourth.
And then this is
all
all
one
over
over
all over secant squared of u, because that's what 1 plus x squared is. And then dx is secant squared of u du.
Is it though?
Right. You told me 1 plus tangent squared is secant squared, right?
I'm saying is the derivative? Are we deriving secant squared u to get the dx?
Yeah. If x is tangent of u, then dx is the derivative of
Yeah.
tangent, which is secant squared u du. Pretty sure about that. So
Oh,
this goes away.
I can still check that though. We can.
Yeah, go check it. Yeah, just
Y-
make sure we're okay.
It's-
I think we're okay though.
Yep.
Because now I have tangent to the fourth of u. 1 minus
Of what?
tangent of
Yeah,
u
or
to the
du.
fourth.
Sure. That equals. So we got the bottom taken care of. Du. You forgot du.
Yeah, sorry, there's a d in there. as
You
well.
forgot du and integration bar.
Yeah.
And the bounds of the integration bars.
I'm not gonna put the bounds in
terms
yet
of
because
equals bar.
well, yeah, because the bounds are gonna change. I don't want to. I'm gonna change them at the
It-
end. I would just don't touch the bounds until the end.
State them as as equals 1, as equals 0 then. Because that's what you would have.
Dissident fonts. I
Yeah,
spoke too soon. I understand how to maybe do this question versus your beautiful question here, which has words I've never heard of, like Ursulon's lemma.
That is draft. That is droop. That's probably draft and droop. Very
yeah.
stuff. So state the bounds as equals 1 and as equals 0. That's what the bounds would be. 'Cause you're
Okay,
not
sure.
changing them. State them. You still must state them.
Okay, for sure. Okay, do we?
Going through steps.
Is this a
Stating
power
them.
reduction? I feel like this is a power reduction I have to do.
I know we don't want. I know we don't want to. I know we don't want to expand that mess in the middle.
It wouldn't be the
That'd
worst
be a
thing
bad
to
idea.
expand. No, it wouldn't be the worst, would it?
Easy to expand. It's actually easy to expand, but I don't think it'd be helpful.
But then
You
I would
wanna
just have a
expand it?
bunch of because then I can just do power reductions on tangent. I think. So
You want to expand it? You want me to show you how to expand that? Easier? No Wolfram. You don't need Wolfram. Let me show you.
all
Let me
right,
show you
I
how
don't
to
need
expand it.
Wolfram. I just need Seth. All right, how do I do it? How do I do it?
1 1 1 1 2 1 1 3 3 1 1 4 5 4 1.
Wait,
You know that?
Is it this? Is it this?
Yep. 1 3 3 1 1 4 6 4 1.
But I don't think I need
And
any.
stop.
Yeah. Okay.
That's coefficient. There's coefficients there.
Got you. Okay. So this is like a to the 4th, and then this is 4
That's the
a to the
statement.
3rd b, 6 a
Yep.
squared b squared, 4
Yep. Yep. I see.
4a
Yep.
b to the 3rd plus b to the 4th. Okay, cool.
Yep.
Good old Pascal. What's up, Giancarlo? Yeah. Okay. So
0 1 2 3 4.
this is the integral from x equals 0 to x equals 1 of tangent to the 4th of u. And
Open
now I'm
hard
going to do all this
parentheses.
fun stuff. So this is going to be 1.
Let's do one. I'm going to do one shift. Inside shift. So we're going to flip the inside. So negative tangent u plus 1. Just so we have we do tangents first.
Oh, okay. You want to really do that? I don't care.
Well, I know we do x first. It's
Well, since it's
Some-
to the 4th power, do I really care?
I don't know, but
Okay.
it's a simple flip. It just
You want to do this?
negative
I know,
tangent u plus 1.
I know.
That way
you,
the tangent is taken care
you
of.
like to do this. Okay, that's okay.
Yeah, it's so negative tangent u to the 4th. That's the easy part. Tangent to the 4th of u.
When you have 16, really? That's nuts. Okay,
In
sorry. So,
fourth-
yes, so that's tangent to the 4th of u, and then that's going to be
And then you have to
minus
it's a t bit for
Four.
tangent,
cubed of u times 1
and the ones are nice. They don't have to tear.
plus
ones.
6 tangent squared of u, right?
Yep, minus.
Minus 4
Oh,
tangent
what do you notice the pattern is?
4 tangent of u, and then
What do you notice?
well, I see the 1 4 6 4 1. That's cool. Is
Nope,
there another pattern
the
I
other
should be
thing.
noticing?
Plus minus plus minus plus minus.
Oh, okay, yeah. Well, yeah, that's because
It
even odd
follows that.
powers.
It
Yeah, yeah,
always
yeah.
evens out. Yep.
Okay.
It always does even odds.
So now I have the integral of like
And then we can
tangent to
take
the
this.
8th,
you
tangent to the
forgot
8th of
something.
u du.
One.
Wait, what? Oh, x equals 0 to x equals
Yeah,
1.
yeah.
Okay,
Yeah,
and then
so
that's
statement.
minus 4. I'm not
You're
gonna write all
be-
the
you're
bonds,
be-
Seth.
you're
This is gonna
say
take me
every
forever.
time the back.
Yeah,
you
yeah,
do that.
that's gonna take me
You
forever.
split 'em up.
Minus.
It-
Okay, sorry.
Copy the integration bars because you don't need it. Copy
Oh.
the integration bars. You have to state the bounds every time.
Okay.
And it, maybe.
Probably could.
Minus 4 of that. Minus 4 of that. And then. What? What? Oh, right. You multiply in. Yeah, I realized. And then tangent 4th at the end. I don't know those. We don't know those yet. We don't know those. So that's.
And
you
sorry,
have to
there's
use
there's DUs everywhere. Just forgive me.
Yeah. All those
Okay.
little things.
Okay.
Nice.
This
Now we're gonna get-
is algebra EOC tomorrow. Got any tips? Work from the outside in. That's how I would say to do algebra. Elliot, if you have a question you want us to go over and like teach you some stuff with algebra, I'm happy to do so. Just submit a screenshot.
You don't know it. I don't
So
know
someone's
any of
saying, can I
these.
take the factor of tangent squared out and write it as secant squared minus 1, and then use the chain rule? Not the chain
No, there's
rule.
no
You
chain-
mean so you mean u sub,
It's-
right?
It'd be used.
So- If you have the integral of secant like tan squared, secant x, tan squared of x dx, it's like a u to u here. Or no, it's if you have the integral of secant. Yeah, this is what he's talking about. So sorry, if you have the integral of secant squared of x, tangent of x to like the 8th or whatever, you can say that
Shift
u is equal to tangent of x, and then du is equal to secant squared x dx. So then this just becomes the integral of u to the 8th.
That's nice.
This
one I don't see.
this is a cool identity. Yeah, if you can pull a secant
This-
squared.
this-
But the issue is that
thing above it,
then I'm pulling a 1 minus secant squared like out of everything.
I don't like that. I don't see it on these though.
Yeah, I mean this is just rough to solve. I know I
And
can
this
do
is
these.
done with maneuver power and go through motions because it's tangent, which is chain rule backwards. Yeah.
Yeah, it's a bunch of power reduction stuff. It is a lot of like 1 minus secant squared, but I have to do it many times. Descendant fonts, is there a shortcut to this? Or is this just like brutal? Because if it's brutal, I don't want to do it. If there's a cute shortcut, I'd love to see it.
What's a power rule, power reduction for tangent then, and see if it does anything.
Yeah.
We can use resources before we use for tangent, of course. See if there's a formula. Then I'm happy. Strolls out,
Expanding it from the beginning, that's the shortcut? Lol. Yeah, he's talking
Yeah.
about this. This is the
that mess.
this is the power reduction.
So it is what we didn't do. So to go backwards.
Femfox says, I think the best bet was to not use trig. Interesting. Yeah.
So do we need to go backwards then? And
Just
go from
long
front?
division of polynomials. So I'm going to show you like what I would have done. To then later go on, you could have done this. So you could reduce tangent to the n of x equal to 1 over n minus 1 tangent n minus 1 minus the integral of this minus 2.
Oh,
Let me see. There's a link.
and you want to do that
Let me see the
for
link.
each of these.
Proof that 22 over 7 equals pi
No, it seats pi.
exceeds pi. Damn, that's pretty cool. Oh, this is the proof. He's saying doing this. Okay, this is the integral we're doing. That's really cool. So
Neat.
So this shows. Okay, so apparently this integral
Is
is equal to 22 over 7 minus pi. Wait, let me see how this works. Okay, so cool. So,
expanded it. That's expansion.
Oh.
That was what we did.
Oh, Seth. Do you see how we should have just expanded? And then if
Yeah.
we did long division, we would have gotten a bunch of polynomials and then a single arctangent that I had to do. Oh, this would have been so much easier. Rather than doing all these arctangents. Okay.
You want to
Very
turn
cool.
around and do
But then
that?
look at this. This comes out to be 22 over 7 minus pi.
Do we want to turn around and do
which-
this again, man?
Well, I mean, this is how to do it. I'm not going to actually do it. Maybe I'll do the long division just to show people the long division step. But everything else is just, I mean, this is simple.
The integration, yeah, is
That's really cool. Yeah. So they expanded, which you remember how I said I kind of wanted to do it, but then we were like, no, we shouldn't do it. Yeah, exactly. So this,
I didn't even notice that on my formula sheet
they
that-
just
ooh, that's
expanded
cool.
out into this.
That I see.
I totally forgot that
And
you
then
could just
I
do
look-
this.
And then here's another thing. When I see the 4 over 1, the 1 plus that squared, I look at our
Yeah.
formula sheet and I see the arctangent formula. And I went, and then I see it.
Yeah. So here, let's show how you would do this. So yeah, you got to go the opposite way.
On
It's got to be the
the-
biggest coefficient first. So right. so this is
not long division. It's long
I'm doing
division, not Senate.
I'm
You can't do that.
doing synthetic. Why can't I do
Isn't
synthetic?
that squared? Can't
Oh,
do
it's 1
so.
plus x squared. Damn.
he's there 4
Oh, I got fucked. Okay, never mind. All right, cool. You right. All right, fine. We'll do it this way.
Has to be the
X to the 8th minus 4x to the 7th plus
Oh, you're right.
6x to the 6th
Nope, there we go.
minus
4x. You're doing.
minus 4x to the 5th plus
Plus-
x to the 4th.
There you go. And then.
And then we're going to divide this by 1 plus x squared.
Plus,
Okay,
But what? X squared plus 1. Because you want to flip it so you can divide right.
sure.
'Cause you're
What's up,
dividing
Reki?
X squared. The
Okay,
left
so
term is
this
what you're
goes
dividing.
into this x to the 4th times, right?
No.
I could-
What? Oh,
Right?
Yep.
So that gets me x to the 8th. And
Minus
then, well, it's
x to
plus
the
x to the 4th. So there's,
Yep.
I think it comes over here. Right? And then I think we subtract, right? So this goes away.
and then you subtract the things, which actually clears the X fourth over there.
Oh, it actually clears this out too. Oh, that's super dope. Oh, that's very cool. Wow.
Bring everything else.
Oh, everyone's like, I fucked up. Wait. No, I did fuck up. Oh, hold the phone.
No.
Hold the phone. Sorry. That's a sad moment. Dude, I fucked up my exponent rules. No. Oh no, boys. I'm so sorry. I'm so sorry. Jesus, dude, that's a classic like 8th grade mistake.
Yep.
I'm tired. We've been streaming for 2 hours, but okay. All right, cool. Thank you.
We're not done.
X to the
yet.
8th. Sorry. Plus x to the 6th. Yes. Everyone in the chat like instantly was like, "No, bro. That is wrong."
But I was saying that. It's like, no one. Okay.
Thank you.
No.
Thank you. Okay, let's do it. All right.
I tended
Let's
to
not-
direct off.
This is 0. So then we have
cancel.
minus 4x to the
We don't need
7th.
0 is not needed.
Well, whatever.
You just cancel.
Okay. So this is plus 5x to the 6th. Yeah, thanks.
Yep.
Okay.
Minus
So-
4 to the 5th plus.
Okay, so now this goes in negative 4x to the 5th times, right?
Yep, which is going to cancel.
Okay, so then we get negative 4x to the 7th.
Minus
minus
4 to the
minus 4x to the 5th. So that's
is
going to
gonna
cancel with that. It's going to cancel
There's
with
a
that.
cancel.
There's a cancel. Goodbye.
5x to 6. 5x
Okay,
to
so-
6 and the x to 4th needs to be brought.
Okay, bring these down.
Yeah, needs to be joined.
Okay, so then this is plus 5x to the 4th, right?
Which is not gonna quite cancel. There's the arctangent rule. There's
Okay,
where
watch
the
what happens.
arctangent-
Yeah, and then this is plus 5x to the 4th. So this cancels.
And that's the negative 4x.
Negative 4x to the 4th. Remainder this.
Over
Well,
that,
no.
which
We're not done yet. Because I can still put this into this.
Yes, you can.
I can put that
That's
in
some amount.
negative 4x squared times, right?
Yeah.
So that's minus 4x to the 4th.
And you're gonna subtract those.
Minus
which is
4x
gonna be fine.
squared. Cool. So now we have 4x squared. Now this goes in 4 times.
Yep, and there's
And
the
then we have
result.
4x squared plus 4. So then I have the
So
minus 4.
And there's the
Yes.
negative 4 from the arc,
Okay, so now we have minus 4 all over this hot garbage. Okay, cool.
which is just
So
right over there.
let's see if we got that right. Yeah, x to the 6. X to the 4x minus 4x fifth plus 5x to the 4th minus 4x squared plus 4. Nice.
Minus
Cool.
the map.
Okay, and then that's this.
When you
Which-
integrate, it's gonna be
Now you just integrate. Very cool. This is obviously 4 times the arctangent of x, which the integral from 0 to 1 of arctan of x is just pi over 4.
most likely doing the
Wow.
trig entities first would still solve. Doing that first, it would still solve. It'd just be
Yeah.
more tedious.
Okay, very cool. So then you get this is 22 sevenths minus pi.
Minus
Oh, did my keyboard just start working? Sorry, one second, my keyboard's fucking up. Okay, there we go, keyboard. Okay, you get 22 over 7 minus pi. And I guess you show that this integral is greater than 1. How do you know this integral is greater than 1?
You don't. You know it's greater than 0.
Sorry,
Which is
greater
what
than
they
sorry,
started.
sorry, how do you know it's greater than 0 though? Because I don't know, it's positive? I guess it's positive? Is it positive? I don't know.
You didn't know that until we solved it.
Oh,
Well, that's-
sorry.
There.
No.
it doesn't. Oh,
I know that this is what the integral is equal to.
but that's not helpful.
But how do I know that everything in
And
the
the
integrand
integrand
is positive, he says?
Because it's a square.
Oh, because of the squares. Thank you, Hamiltonian dynamics. That's brilliant, dude. Yeah, okay. Thank you.
Neat. More problems, right?
See, dissonant fonts, that was a very cool question. I really enjoyed this. I learned a lot of shit today. This is really cool, actually. Yeah, so
So we did
because
spot,
this is even, that means this is all positive, and the integral of just positive shit is positive. Nice. Good job, Hamiltonian.
Yeah, two
dynamics.
on
I
the
appreciate
other
that.
page.
That was cool.
And more.
And
Let's see.
Dissonant
So
fonts
yeah,
for submitting it. That was really cool. Really cool question, dude.
Two more, I think.
Okay, 2 more, because I'm getting hungry. Where?
And then
Where are the
yeah,
2 more?
We talked about and have some fun with.
What are the other 2 that you saw? Sorry.
Swaz and Team 9 on help screenshots under
Oh, okay.
today's date.
Oh, I know this one. He wanted help with 89. He DM'd me earlier this morning, but I'll do it for him.
89
anyways.
is the one that's on,
Yeah, he needed help
and
with
the other
89.
one is the about yuck.
I'll just do
the-
89. Let's just do 89. This is
And
the
then
one he
the
asked
other
me for
one,
help with.
Team 9, the other one, yeah, the other person was D.
Okay.
But
I believe this is USub, right?
no, it's actually on my sheet.
Sorry, integration by parts. I think I say that
No, it's-
U is equal to ln of x, so du is equal to 1 over x dx. And then I say v is equal to x dx. So dv is equal to x squared over 2, right? Sorry, no, I'm really fucking up, dude. Sorry. dv is x dx, so v is equal to x squared over 2. There we go. So this is equal to ln of x squared over 2, minus the integral of v du. So that's x squared over 2, 1 over x dx.
Okay.
So
And
that's
what part is
minus,
that? Did you-
that's so nice, right? Isn't this just minus 1/2 integral of x dx?
Yeah.
Which is just x squared over
X squared.
2. So this is all equal to x squared over 4, right? With the 1/2.
And then put the side onto it.
And then put the c. Okay,
Yeah,
cool.
And the C, and also write it, and then put A on the sheet.
So yeah, it's 1/2 x squared ln of x
Minus-
minus
Minus
x
minus
x squared.
1/4 x squared, because that's how you would
Minus-
write it.
Sure, minus 1/4 x squared
Writing them all the same. Yep.
plus c.
Plus C.
Nice.
And
That's a cool question.
equals A and
Yeah, that one's not too bad.
Are we doing the other two?
The general strat, if you're looking at this from a calculus standpoint, people always ask me like, how the fuck do you know what to do here? If you ever see something that would be nice if you could like just get rid of it, then you probably want to do like integration by parts. Like for instance, if I see something that I know how to derive and I know how to integrate, but I don't know how to do those two things together, integration by parts sometimes separates it out so that things will, like in this case, things will cancel. And then
that'd be nice.
and then it'll be nice. So anytime you see the integral of two things together that separately would have been easy, try doing integration by parts.
So what about the other person? I like
This
the
one?
integral part of that. I like the integral one, not the proof one.
Femfox says differentiate. Creating integrals
also-
via wishful thinking is a good exercise before doing these kind of problems. Yeah. Yes, I like
you
that.
could
Manifesting.
You could
Are we
do
talking about-
derivatives. And just go from the answer choices. of
Yeah, if you went
course.
backwards. Oh, that's hilarious, Femvox. Yeah, because it's multiple choice, Fem's like, you could have just taken the
I'm gonna-
derivatives of these.
One, because I know
Disqualified.
No, dog, that would suck though. I guess it technically would work.
No, it's
but-
not. It wouldn't. Two's definitely wrong. Two's definitely not going to be that.
Bro, I'm doing those integrals
not.
right now. What the hell?
Four's not.
Yeah, dude, the algorithm, bro. The algorithm knows, bro. Also,
think
there are
two's
only
not
so many.
bad.
There are only so many exercises out there that kids are doing these days. So, prove the
I don't
minimal
like that.
positive solution is transcendental. What does this
I
mean?
don't like that one. It means that it's like pi. It's like series or something in that nature.
Bro, are you watching me? I just got assigned integration by parts yesterday. No, but the algorithm is. The algorithm 100% knows that
might
you
be able
did
to
integration by
manage
parts. That's why, bro. Yeah, this
We
guy's
might
asking.
manage
Like,
27.
how does he know? The algorithm knows what you're doing. Also, it's the end of the school year. I guarantee you're doing integration by parts.
We might doesn't satisfy a polynomial equation.
Do we want to do this one? Do we want to do this
That
one?
one's manageable.
I'm almost
Man,
done
that
with
one's
pre-calc,
manageable.
so I'm gonna take calc 1 next year in college. Cool, man. Calculus is cool. Feel free to come by next year. We'll be here if you want some help.
Addition of 2 integrations. So
Uh,
the left side was a little bit sus. What's at the bottom of that?
Yeah, the 1 plus x squared. I don't like that.
And yeah, came back, but it doesn't have. The right side is in.
Oh no. Ooh. No. Ah. I want to say like if u is equal to ln of 1 plus x, then du is equal to 1 over 1 plus x. But I need 1 plus x squared. USub doesn't work. This is proof the government is watching you. I didn't even search it on my phone. Yeah. They know, dude. They all know. Okay, wait, how do you do this?
Probably have a,
Do these have like some weird shit going on? One sec.
because the number 25, I assume so.
Let's throw it at the dolphin killer, dude.
It's because the number 25, I can
ChatGPT.
Don't
My
do that
beloved,
yet.
go for it.
You can always write it.
Go for it. Have fun, ChatGPT. Enjoy eating some water bottles of cooling. Uh-oh. Import math
okay.
pie. Ooh.
It's doing through it.
Oh, it says Catalan's constant. Okay, one sec. I'm gonna
Probably
listen to my.
so.
Let's
It's
listen to the
probably
chat real
fine.
quick. Let's listen to chat. Chat says, do integration by parts for the first one and add the rest. John Carlos says because the second one has arctan. So are you saying I should combine these integrals first because they have the same
We can do
bounds?
that, 'cause we can do that.
So I could do ln of 1 plus x times x plus x squared. No, sorry, plus 1
You're
plus
fine. You're
x
fine. You're fine with
squared.
that. Nope, wrong. That's definitely wrong.
Why is it wrong?
1 plus x to the power 2 is not the same as 1 plus x squared.
Oh, you're right. Thank you. And then you want me to do this all over x 1 plus x squared?
Nope, that's still wrong. That's still wrong.
Yeah.
1
sorry,
plus x to the power 2
I
is not the same as
keep putting my things outside the parentheses.
And the integration. What are we integrating with?
Yeah, I don't think this is really nice though.
Well, when there's the integral exponential of x, but none of that.
Teaching at UCLA has really broken you. Fortunately has, dude.
Is-
Yeah, I'm a broken boy.
What is it saying?
If you do it by parts, then you'll get tangent x.
Or tangent
Breaking
of
news:
x.
UCLA professor gets addicted to LLM. Proof they are like us, the students. Someone says U sub
U
1 plus
sub one.
x. Let's do it. Let's do it. Let's just do it.
What is ChatGPT?
I'm
saying?
listening to chat. I'm listening to chat. If you say u is equal to 1 plus x, yeah, the issue
Yeah.
there is that du is
make-
just equal to dx,
I don't know.
which doesn't really
Yeah,
help me
maybe
out
I
there.
don't know, but you're leaning towards not.
Ooh,
working.
ooh. No. I was thinking if I could write that as like u. Is it like if this is 1 plus x, right? Then u minus 1 is equal to x. So x squared is equal to u squared minus 2u plus 1. So x squared minus 1 is equal to u squared minus 2u. Right?
Yeah.
That's pretty
Yeah.
cool.
Natural out
So-
of u over that.
So then that's
Hint,
ln
derivative
of u over
You got a
u
hint, but
u minus 2.
Got a hint.
Hint derivative of arctangent. Okay. All right, let's go take the
The
hint.
derivative of arctangent. I have
don't.
it on the sheet.
What is it? Is it 1 minus u squared or
Let me see.
something?
Derivative of arctangent.